Good morning, everyone, and welcome to the third part of our series, BIM for Building Product Manufacturers. Today's presentation is Creating and Publishing Revit Families for Manufacturers. Today we will pick up from where we left off on our last presentation, Preparing Your BIM Model. We will look at those models and see what comes into Revit and some final steps that can be taken to finalize your model so that it is ready for the designer to use in their projects. We will also discuss how we can get our content into the hands of those designers. M2 Technologies is a consulting firm that works with Autodesk products as well as EdgeCam products. Our focus is manufacturing and the software and tools that support that industry. We provide training for both software groups at our authorized training locations, or we can create custom training to fit your needs. Our technical consultants have a large range of knowledge on the industry, the software we use to create our products, and how our products are being used by the design community. We also have software developers and account executives, as we are also a reseller for both Autodesk and EdgeCam softwares. Our office locations listed here on the right indicate our main offices and training centers, but we can help you wherever you are, even if you're not near one of these listed locations. My name is Louise Buchanan and I will be your presenter today. Just to give you a little information on my background, I am a business development manager here at M2 Technologies, and I have extensive knowledge on the BIM process. I am an expert in Revit, Navisworks, SketchUp, AutoCAD, and a few of the AutoCAD verticals. I have over 15 years experience working within the AECOM industry, and currently my main focus is working with manufacturers and building content that is BIM ready, but not only that, to make sure that it meets both the needs of the manufacturer and the designer so that it includes both the data and the options and functions of the manufactured product. So let's start talking about creating and publishing Revit families. In our first webinar, What Does BIM Mean for Manufacturers?, we discussed the meaning of BIM. I will let you read the definition here, or you can watch our first webinar to get more details on this topic. We also discovered that ways we design has changed, and that our target audience's needs have also changed. As consumers, we want the best solution at the best price. Basically, there are many reasons for us to get involved. The industry is changing, and we need to change with it if we want to stay ahead and be business leaders with our products. By targeting a broader audience, we are able to open the doors to more opportunities. Along with discussing how we can gain new business and new opportunities, we discussed in last week's webinar levels of development, where we fit in and what we need to provide to our consumers. We looked at the fact that our consumers are not just owners of these buildings and the products that go into them, but they are also the designers that pull these buildings together. And therefore, we need to provide our products in a way that are the solution for these designers and what they are looking for. We have our fabrication models that may be at the level of detail as what we see in this FM picture here, but we sometimes have to provide a model that is one of the three middle pictures that you see in this picture below, so that we can get spec'd into more projects. That is what we want, right? To get more projects and to win more business. So that led us to look at the requirements. How do we compete and do it well or better than our competition? In our last presentation, we looked at what is required of us to have BIM-ready content and still hold true to what our product offers. The geometry and the data is where it is. How that information is utilized will shape the project, and how the designer finds this information will shape their decision on what products they use. Now that we have done a mini review on some of the topics that have been touched upon in this series, let's look at the final steps we need to take on the Revit side for our consumers that are using Revit and need your content ready and available to use in their design tool. Our next steps is to finalize the models so that they satisfy the needs of the designers and hopefully exceeds their expectations. Once we have the exported RFA, we will need to do a few steps in Revit to make sure that it is ready to use in Revit, with all the corrected data and elements and the properties to be effective in the design environment. So now we're going to take a look at the blower that we've got from Inventor. When I open the Revit file, this is what I see. So you can see that the level of detail that we saw on the Inventor side is the same, and we are able to basically take a look at the information and data that came in. So you can see it has connectors on it already. The data that came in from the connectors, you can see pressure drop actually has a value filled in. It is coming in at a particular flow configuration and flow direction, so that will actually translate through our system. And if we want to look at the data that came in for the entire family, we can take a look here, and I'll just expand out the identity data here. And you can see that the model number and the manufacturer and the main URL information came in, as well as the description. We can absolutely put in additional parameters and values in here. I can start filling in a cost value if I'd like. And basically that information will then be translated to our Revit model, and we can actually schedule it as part of the project. So we can start getting cost values if we want to in our project. You can add in additional parameters like some of the spec information or operation manual information, and then that can also come into a project. So now what I'm going to do is I'm going to bring it into a project so you can see the Revit project environment. Oops, wrong project, wrong button. Use a mechanical template. And I'll just go back to the blower and load that into my project. And then place it. And I just want to zoom in here so you can actually see this. This is from a top view and a plan, floor plan view. And so we are able to see the level of detail in that view. You could absolutely simplify this more inside of either the inventor side or on the Revit side, depending on where you want the simplification to happen. And I can also, you can see here that I have my 12-inch out and my 9-inch in. So I can actually right click and do draw duct. So I can start drawing a duct system. And as I start drawing that system, since it is an out, it actually highlighted this whole system as being green. That is just a color filter that's associated to this particular template that can absolutely be changed to some other color scenario or no color at all. And if I come in on the 9-inch inside, do the same thing, right click and draw duct. I can start drawing. You can see it is a smaller pipe. Up here at the top it'll say that it is a 9-inch pipe. The pipe is blue for the in and green for the out. Again, that's just part of the filter. What you'll notice is that the item in the middle, our air handler unit, is not colored at all because it has both the in and the out systems connected, so it's a multi-system. And in that regards, it will still schedule on either side if you're doing your supply side or your return side. You can definitely see that information in there. You can get scheduled information on just air handlers in general, and that this piece will come in there, and any of the filled in parameters that we saw, that information will also go into our schedule. I can change the level of detail to coarse, and what you can see here is Revit did exactly what it should have done, is it turned our pipes to just a single line, and so that we can do a single line diagrams. It did not do anything to our air handler unit here because it was not set up to do that. That can absolutely be set up on the Revit side or in the inventor side and then exported out to Revit. It depends on where you want to do the data. You know, the designer may want to see some type of symbol that is for an air handler unit, which it could be as simple as just a square box with an X through it, depending on what that symbol needs to be. Or you could just make it a square box, and you can include that either on the Revit side or the inventor side, like I said before, and then it will show the level of detail change when you change it from a coarse detail to a fine detail. If you're looking at it in 3D, you'll want to see the fine detail, so it's three-dimensional most of the time. And so now what we're going to do is we're going to go back to our webinar series. I'm going to talk about a couple of different family type and some of the parameters and options and things we can do on the Revit side that we may not be able to do prior to an export. So for the blower, this is a perfectly acceptable workflow to quickly give designers your model in a format that they can easily work with. When does this process not work? Well, I like to think of it as the more complex the geometry and the more complex the options are for dimensional and material changes, the more likely it's going to be that you're going to need to design this natively inside of Revit. I want to take a look at another family type that we sometimes need just a little bit of flexibility from the model that we can't always get straight from Inventor, but we can at least start with the geometry and the information that we get from the Inventor model, but then modify it on the Revit side. So this is just a very simple table that's available in Configurator 360, And when we take a look at the options, you can see that you can change like width and dimensions, height, depth, and some other inset options for the legs. You can basically look at the different outputs. And so what we're going to do is we're going to output this to an RFA. And when we do that, basically what will happen is that you will only get the one size that was available at the time that you did the export. There's not a way to actually export all of the different sizes from either Configurator or Inventor when you programmatically put that in. It will only do the size that was actually listed at the time that you did the export. So it doesn't make it flexible in size from an export. You have to do that after the fact with a little bit of configuration on the Revit side. What I did want to show you is that the materials, you can see that it did come in with like an orange top, and it has, in this case, white legs. What you'll find is that when you change the visible look from a shaded look, which is what it's in now, to a realistic, which is like a very low-end rendering, it shows up as being gray. Now, the different Autodesk products like Revit, Inventor, 3D Studio Max, and a few of the other ones, AutoCAD Architecture, they all share the same render library. So as long as you're using out-of-the-box render materials from one software to the next, they usually will transfer over pretty easily from one product to the next. What I want to do is I want to take a look at the materials for a second. So what's being used for the legs is this chrome polish, and for the top it's this white oak natural gloss. Now what happened is that the appearance did not get brought over, so it's just using a generic appearance, so the appearance asset needs to be attached. And we can easily do that by going into the assets and just searching, in this case, white oak. And here's the white oak medium gloss, and I can just basically click this button here to change that and to add it. And now it'll have an appearance asset of white oak. And then I can basically do the same thing for this chrome polished. And I'll do it a different way by telling it to switch. And then we can come here and do chrome polished. And this one here. And then we'll close that. It's just going to update it, so now it gives it a chrome polished. The graphics right now is set to this whitish color, so that's why it's showing up as white. If I just basically change it so that it's more of a gray color, you'll see a physical change there as well. We'll hit OK. So now you can see it's giving it more of a rendered look. It looks black in this view just because it's a low-end rendering, but if you were actually to run this at a high-end, you'd see it with the shiny chrome polish finish. If I change this back to a shaded, you'll see that the legs are a little bit more gray than white from what they were before. So we can easily affect that. The problem with this is that it is only giving us one finish option for this, and that's it. So if we had a table that had different wood types or different leg options or materials for the different parts, we can't do that from this export. So we actually have to do it ourselves. So what I'm going to have to do first is actually take this and explode it. And exploding doesn't always work when you do it from an Inventor import. In this case, because the geometry was simplified enough where it was shapes that Revit understands, it exploded actually pretty well. What it still is doing is it's making this whole thing one surface, or one shape, if you will, instead of the legs being separate from the top. It did remove all of the materials when it did this, which is fine, because what we want to do is we want to go in and add some material parameters to this. So I've actually preset up a project that has the material parameters already pre-created in here. I just called it tabled legs and tabletop. And so from here, what we're going to do, or what we would do in this case, I'll just go back here for a second. Let's just go back to this project, and what we can do is we can actually come in and make two new materials. Table leg. Oops, sorry. you got to remember when you're making materials that you make them an actual material type. And make another one called tabletop. Make it a material type. And it's okay that it's set to by category right now. What it will make it a little easier is if we hook it to the different materials that we had. That is table leg, so we'll set it to the chrome polish. And then we're going to come into tabletop here, and we're going to set that to the white natural oak. And in this case, what we can do here is we can, now that this is exploded, we can actually paint the surface. And with our paint tool, we'll paint. And I want to add the actual table leg parameter. And I'm just going to, you'll have to do this by face. So you're going to go around to the different faces here and tab through, and you can see that it'll actually start getting lighter. I'm just going to do some of these faces. I'm not going to do all of them right at this moment. So you can just see that, and then we would do the same thing with the tabletop parameter, not the white oak, and start painting some of these surfaces. What is nice about that is now that we have parameters in here, we can create types off of the parameters where we can change the material. So if this has different options, like maybe there's a glass option, if I now come and I change this to a glass instead of it being a wood and hit OK, you can see that it actually physically changed the top to being glass. So that is gives us a little more flexibility with materials. The next thing that we might want to do with this table is we might want to go through and add in some dimensions. So I'm going to start in a top view, and I'm going to put in some reference planes here. Because this is an exploded item, you do have to just do some preset up with this with some reference lines and some dimensions. And what I'm going to do first before anything else is I'm going to just align the geometry so that it's going off of the actual location here. And then I can start putting in an EQ dimension, both sides. And then we can put in a dimension that we're going to use as our width and length of this table. I like to try and keep my dimensions organized. The one thing that we do need is we need the edges of our geometry to actually be locked to these reference lines. And I do want to see the table legs, so let me just change this to a wireframe so I can see those little table legs, because we also are going to need those table legs to be an adjustment off of the different edges of the table. So we want that to be a locked dimension as well. And we can share these reference lines across the entire length. So if I just bring this down all the way, same thing with this one. And you don't have to bring these all the way over, but sometimes it's a little bit more easier to deal with the line types if you can see them just a little bit better all the way across. So great. Like so. And then the same thing as I'm going to align the geometry, if it lets me, to the legs, which it doesn't seem to be allowing me. Maybe I do it this way. Here we go. Lock. And the only thing I didn't include was a reference plane for the inner part of the leg, so we're going to put that in. And then again, align And then do the same thing for these upper ones. I'm just going around all 4 edges here on each of the legs. And then the last step that we're going to do is we want these legs to basically be a locked dimension from the edge of the table, like so. So what we do is we basically just lock these up to these locked dimensions. And obviously, you know, if you wanted them to be the same, like this side has a 125, this side has a 95. If you wanted them to be 100, you'd change that first. And so then we can basically start creating our parameters. And we'll just call this one length. Do the same thing for this one. Call it width. Okay. And we're going to flex the model. We'll go to length and change this from 1500 to 1600 and from 800 to 900 and hit OK. And you can see that the length here changed to 1600 and the width did change to 900 and the legs are still within those little tiny rectangles. So it means that it kept those distances of the 125, the 120 and the 95 that it has all the way around as it flexed the shape. If I Control Z, you can see it all flex back in. So just back and forth between that. So what this is going to allow us to do now is to actually go through and create different types by the different sizes that this table comes in on the Revit side, and then this information can then be exported into a project or saved as this file and then exported to a project so that the designer can then utilize this information for all of their projects. As you can see in the table example, we can still use the geometry and the data that was exported, but then we may need to do a little work in the Revit environment to make it flexible in accordance to the options that this product is available in prior to giving the final product to the design community. A few product groups that do not work with this export example are pipe fittings or cabinetry with multiple door styles and sizes. Light fixtures are just a few examples of some categories that are better handled natively in Revit versus using an export and bringing it into the Revit environment. Light fixtures have a lot of mechanics that need to happen natively in the Revit file in order for it to work properly, to allow for sustainability and lighting analysis and those type of mechanics. So I'd like to take us and take a look at a light fixture just to see the options and see some of the things that don't come over from Inventor through this export process, and where it makes more sense in this case to create natively inside of Revit. So this is a light fixture that the company's name is Del Rey, that was completely made natively within Revit, and it has many different options. So these have 3 different rings. If I just scroll this around here, you can see that it has 3 different rings in here. These rings are actually flexible so that they can rotate in multiple different orientations, so that the light can shine in different directions to give a different perspective or a different look to the space when it's actually put into an actual architectural space. So if I take this into that environment, and what I'm going to do is I'm going to just basically take this and I'm going to load it into a project that I have already preset up with a ceiling. And I'm going to place this in my ceiling. And if I look at this in a 3-dimensional environment, I've created this so that there is a ceiling, but there is no floor, just that we can see this a little bit easier. And so here we have the product, and you can see that it has the 3 rings. And within here, you can see that it has an outer ring tilt angle that sets as 10. There's an middle ring tilt angle, and there's an inner ring tilt angle. So I could absolutely set all of these to 0. And when I come over, it completely puts them at more of like a cone shape. you know, and you can completely go and change the distances. So you can see that this is set to 5'6", 5'9", and 6 feet, and that's giving it that more of like a, I guess, a pyramid scenario. But if I set all of these to 5'6", they would absolutely flatten out. And that is what's going to control how this light is going to shine off of this object. If I go and I turn on the light source, you can actually see that they're, right now they kind of look like they're overlapping each other, but there's actually 3 different balls of light. And as we take this fixture and we tilt this at 30 degrees, you'll see that this one is now tilted like so. If we take the next one and we make this to be 15 degrees, you can see that it's changing so that now you can actually see that there are 3 separate balls of light, and that's going to affect how this renders within a scene. And so what's happening is that there's an IES file that's attached to this. It's giving you this ball of light that's been given to us by the lighting manufacturer. And to allow us to do sustainability tests, lighting analysis tests, you know, test how much heat is coming off of this product within your space along with everything else that's in the space. And if we didn't have that IES file, we wouldn't be able to run those scenarios to get some photorealistic lighting effects in our space. So those are very important pieces for talking about sustainability, and the designer is very concerned with being able to run those different analysis on their project, not just putting in a light fixture and call it a day. They want to see what it looks like. They want to see what the options are, in this case, how it can rotate. And this functionality can't be done in Inventor and then exported to Revit and call it a day. We can absolutely use the Inventor models to give us a 3-dimensional look and feel of how this product is, but then it makes sense in this case to actually rebuild the 3-dimensional geometry in the Revit environment so that it can actually work the way that Revit intends light fixtures to work for this regard. In conclusion, exported models from Inventor to Revit will work for models that do not have many size options or material options. One of the options we looked at was completely reusing a Inventor model straight from Revit, with just taking that model and bringing it into our project, and we're able to use it. The second option we looked at is taking the information that we get from Inventor, doing a couple of minor changes to it in the Revit environment prior to giving it to a designer. And the case that we used was the table example for that, where we added some dimensional information and some material options to that. And then the third option that we looked at was where we really can't use the export straight from Inventor. We can absolutely use an Inventor model to create those 3-dimensional shapes and kind of use them as a tracing method. But we may, in some regards, for certain product types and groups, we may need to actually do those natively inside of Revit so that we can actually get the correct information off of them. So there is some benefit to utilizing the Inventor model, but there's absolutely some places where it won't always work. And so we do have to just know when those places are and what steps we need to take to make sure that we're providing the best quality item out to our consumers so that we're giving them the best options. M2 Technologies is the consultant that can manage and ensure that the content is properly formatted and globally available to ensure inclusion in design and construction models, practically creating a design-in deliverable. We can work with you and your designers to deliver a solution that will best suit your needs as well as the needs of the designers. Our experts are able to show you the best solution to be competitive, provide quality designs that are configured to a designer's needs in multiple design stages. We can create the content for you in multiple formats or provide education and support to ensure that you can provide these out to your engineering and design customers. M2 Technologies is the consultant that can provide the process to ensure that engineers design a system that they are able to make informed decisions on the interworks of the building. So now we have these BIM files, but how do we tell the world that we have these files? Well, the first step is definitely getting them published to your own website. And this might be the only solution you need if everybody knows your brand name. But if they don't, or you want to reach a broader audience, then you may need to reach to groups that do not know you. You may want to look into hosting to other websites that designers frequently check for manufactured content. There are many out there, and we can absolutely help you with the best solution on which website is going to work the best for you. We can work with you on creating press releases if that is a need that you're looking for. We've also have the capability in-house that if you're going to be at a show and you want some marketing equipment or marketing brochures and things like that to put at your booth at a next show that you're going to be at, we can absolutely help you with those pieces as well. So definitely look to M2 for some of those marketing solutions, and we can definitely have future conversations with you around the best solution that fits your specific need. We're confident that by working with large existing design firms and large construction firms and large owners, we can prove this out and have an extremely powerful presentation and approach to the manufacturing sectors and that the designers are looking for in order to look to you as the manufacturer or as a solution to their needs for their projects and hopefully use you on multiple projects as they work through their process. So we can absolutely have more in-depth conversations about this moving forward. So for more information, you can absolutely call us at our 800 number or 877 number here. You can contact us via the web, or you can email us at support@m2t.com and our info@m2t.com, and we can absolutely get in touch with you to create a solution that best fits your needs moving forward. Thank you for your time today. Thank you for attending this presentation, and we hope to hear from you soon. I hope you have enjoyed this webinar, Creating and Publishing BIM Content for Manufacturers. This is the third installment of our three-part series, BIM for Manufacturers. You can connect with us through these medias for further information on M2 technologies, the products that we support, and the work that we can do. Thank you for your time today.